quotient rule in other sources, one way to think about it, or one sort of trick to remember, is instead of thinking about numerator and denominator and F and G, you talk about high and low for the numerator and the denominator. And then you kind of get this like little sing-songy thing. You use the letter D to represent the derivative. And so if I want to take the derivative of high over low, it's low times the derivative of high, because low is the denominator and high is the numerator. Low derivative of low d high, or low times the derivative of high, minus high d low, numerator times derivative of denominator, over low, that's the denominator squared. And then you can kind of like do a little like low d high minus high d low over low. And you get that little sing-songy thing, and sometimes that just makes it easier to remember. Low d high minus high d low over low. And Mr. Walters talks about that all the time, and he uses that. I had this totally goofy teacher for calculus my senior year, Mr. McCorkle. Mr. McCorkle talked with a fake accent sometimes. I don't know why. He'd say, "Hey, hello there. What you doing?" I don't know what that was about. And he taught us quotient rule as high over ho. Not low, not high and low, high and ho. And so then he would walk around and go, ho-de high minus high-de ho over ho-ho. And then we would say that, and he would go, hi Santa, Merry Christmas. And he would think it was hysterically funny. It wasn't, you know. I still though, I mean, that's like my little homage to Mr. McCorkle, because honestly, when I think about quotient rule, I do ho-de high. I go ho-de high minus high-de ho over ho-ho. Because that's what Mr. McCorkle taught me. Ho-de high minus high-de ho over ho-ho. Hi Santa, Merry Christmas. So, I put that on there. Mr. Walters, he may have deleted it from his copy. I left it on mine, because I like it. So, whatever you do, whatever works, numerator and denominator, low and high, high and ho, whatever trick you can use, you got to memorize it. Denominator times the derivative of the numerator minus numerator times the derivative of the denominator. If you look at that, it's the same order as I taught you in product rule, which is why I taught you product rule that way. GF prime, FG prime, just a minus instead of a plus. And then G squared down at the bottom, that's like not a calculus thing, that's just whatever G is squared. So let's try it. Here's our function. I'm going to let low or F or actually, see, the high and low can't do it that way. I'm going to talk about the numerator. I'm going to talk about F. My F function, my top function is 2x minus 1. So F prime would be just 2. Everybody okay with that? If F is 2x minus 1, F prime is 2. Yeah, okay. So G being 3x plus 2, G prime is just 3. And so now I'm going to build my derivative. Denominator, or G times derivative of numerator. Low. Start down low. That's a good way. If you do the high and low, that's another way to remember. Like, where do I start? I should start down low. Start at the denominator. 3x plus 2 times 2 minus 2x minus 1 times 3, all divided by ho-ho. Low. Low squared. 3x plus 2 quantity squared. There might be other devices out there to memorize it. You'd have to Google and look and say there's probably stuff out there to help you remember quotient rule. I always do no, but yeah. Quotient rules are ugly. Luckily, we we don't usually have to do very much with them. Most of the time, once we build one, we plug a number into it, so we don't have to clean them up very much. This one we are going to clean up a little bit, because I want to make sure we talk about stuff that you can't do. But before we do that, is everyone okay with where all my pieces came from? My low, my D high, minus high, G low, low low. O D high minus high D ho. Merry Christmas. I don't even know. I forgot. I was going to be golden last night. I don't know if he's still alive. He was not young when he taught me, and I was 17, and now I am more than that, so by 30-ish years. So, yeah. I don't know. He might still be alive. He's probably in his 80s or his 90s, though. All right. What can we not do? This is the one that you want to do so bad. You're like, I'll cross one of these off in this. Algebra says you can't do that. You cannot take a factor out of this term and a factor out of the denominator without taking the same factor out of this term. This is the difference. If I want to take out a 3x plus 2, I better take one out of here too. These are two terms separated subtraction. So crossing things off, you're not going to do that. Don't do that as much as you want it. You're like, that would make it so pretty. And it'll also make it wrong, so don't do it. This is not going to cancel. You're always going to see this. It's always going to be there tempting you. Look, cross me off. Don't cross him off. They don't divide out because you don't have one in the other piece. As far as simplifying these, most of the time, the denominator will be left as g squared or ho squared or whatever. So, and when you look at your multiple choice answers, you'll see that. So you rarely need to expand this. Typically, if you are simplifying, it has to do with doing something in the numerator with those pieces. So if I build this, if I distribute through the 2, and I get 6x plus 4 with the 3x plus 2 times 2. And then, here's the other part that's very tricky. It's a minus, so I've got to make sure I'm distributing distributing a negative or a subtraction and the 3. So it's going to be a minus 6x, but it's going to end up as a plus 3. Right. The answer we would be wanting to look for here would be 7 over 3x plus 2 quantity squared. That would be a good answer. Numerator, a lot of cleanup. Denominator, nope, let him sit there. Yes, sir.
Would they accept it if we FOILed it out, the denominator?
Sure.
Okay.
But it's a waste of time, and we don't want to waste time. Right? So, yeah, it's not wrong, except if you do it wrong. Right? If you make a mistake, then you've almost like not erased, but you've taken away from what you've done. If you go from here to here, and you go mental, and you tell me my denominator is 9x squared plus 4, it's like you just shot yourself in the foot. Stab yourself after you did all that beautiful calculus. So quit. Don't do more than you have to do. It's not going to get you any extra points to do extra stuff. All right, other questions? Like I said, I feel like quotient rule always is, it's yuckier to write it out, but it's easier to remember that you have to do it because it's already creepy looking, so you're like, oh, what the heck am I supposed to do? And you're like, all right, yeah, there's this whole formula I have to do. Now, can we change things so that they're not quotients? Sometimes. Sometimes we can make it not be a quotient. If we make it not be a quotient, then we don't have to do quotient rule anymore. So for example, for problem number 10 here, if I did this using quotient rule, let's go ahead, let's do that first. Do number 10 using quotient rule. Ready? Go. Do number 10 using quotient rule, and then we'll talk about making it not a quotient. 3 over x squared. Hit it with a quotient rule, get me a derivative if you haven't done it yet. Where did I? Flash. Here real quick. Oh, yeah, I'm recording. Okay. Alright, y prime. Y prime equals, start down low. So x squared times 0 minus 3 times 2x all over x squared squared. Everyone all right with those pieces? All my highs and lows and D's and... So I think we're going to look at negative 6x, 0 minus 6x. So negative 6x over x to the 4th, which is equivalent to negative 6 over x cubed. Now, here was the point. 3 over x squared is the same as 3 times x to the negative 2. You can write quotients as products. This particular product, you don't have to use a product rule on, though, because it is a product with a constant. So if I took 3x to the negative 2 and I said, give me a derivative, I'm hoping you would tell me negative 6 x to the negative 3. Applying power rule, exponent comes down to the front, exponent drops by 1, which is the same as negative 6 over x cubed. So absolutely, there are quotients that we can rewrite in alternate forms, and then it may be possible to then attack it, finding the derivative with the alternate form. Some students really look for that a lot. Some students don't. It's interesting when you see Mr. Walters and I do keys, when we run into a problem, like I'll do a quotient rule sometimes where he'll rewrite it first and then do something else, and so it'll look to like, it's just our minds think differently when we look at it. I typically don't look at rewriting it. I mean, this one I probably would, honestly, this one I would, but, and this will be the last one we're going to try. This is a perfect example of, you can rewrite this and find the derivative. And it doesn't have, and there are multiple ways to do that versus quotient rule. I would automatically, I'd look at that and I'd do quotient rule. I wouldn't do anything about it. I'd just like, oh, it's a quotient, I'm going to quotient rule it, blah, 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 here I go. Others, though, you may look at that and think, hey, I can do something else with it. I could, and then do the derivative. So one option would be, you might look at it like that. If you do that, then this is the same as x plus, and that I probably wouldn't leave as a quotient. 1 over x, I would write as x to the negative 1, and then you can take the derivative from that. You could also take x squared plus 1 times x to the negative 1, rewrite it as a product, and do product rule. But you could also do quotient rule. You've got at least 3 options to generate your derivative. I'm going to ask you to try finishing that one using any technique you want. It would be probably good to do quotient rule and then try one of the others. I will tell you no matter what technique you use, the derivative you would get should be equivalent to 1 minus 1 over x squared. And so for this last problem, if you want it, running it with quotient rule, I think that's a good way to do it. That's how I would probably do it. I would just hit it with a quotient rule, simplify it. You're not going to see the answer maybe exactly like 1 over 1 minus x squared, but hopefully we can match it up. If you run it using a product rule, I think it'll be more obvious that the answer will be 1 minus 1 over x squared. Dennis, question. Because I apparently, oh no, I'm not wrong this time. That's like, because I'm stupid, but I'm not stupid in this one. X to the negative 1, when I take the derivative of that, that's negative 1, that's okay. Right? Yeah, so it's plus a negative 1 over x squared or minus 1 over x squared. Okay. All right, I'm going to let you fiddle around with that. Homework-wise, I want you to finish the rest of the problems in the packet. There are some other problems that have to do with the tables up to lesson 8, so don't have to do lesson 8 yet. So finish of the points. This test was worth 47 points, so 10% was 4.7. We went ahead and just shoved that up to a 5 because we're not doing anything to your quiz grade. So you've got that teeny little bit, okay, extra. So your score is in there as a raw score. Those 5 points are in there as extra credit. Your grade is calculated as a total points. So it's all getting added and divided, and I'm happy to go over that with you if you're not sure how that's working. Unfortunately, if your raw score was such that even adding 5 points on doesn't bump you over 50, you're not going to see any additional points. You're going to still just see you got the minimum 50, okay? We don't take you, if you're, that's self-explanatory. And once again, if you have a concern about that, I'll be happy to talk to you. We're gonna come up with a plan for the retake and a deadline for that. He and I are meeting today during 6 to talk about that. We are also probably gonna talk about doing some kind of corrections for homework points. So I'm going to come back to you with some more information on Wednesday of next week. I need your test back before you leave. Your test does not leave with you. You can look at it today, but then during learning seminar or after school or any other time, you're welcome to come look at it. And we may be using that to do some corrections. Okay? I think that's all the things I needed to tell you.
Oh my God.
But if you have any individual questions, I will be happy to answer. All right. So I need it back when you're leaving. The retake would be, the maximum score you would get is an 80, no curve. Right. So if your curve score is over 80 or greater, there's no benefit to retake. You would only retake if your curve, even with the additional points, if your curve score hits you less than an 80.
Minus 1.
Jade.
Oh, it's the top of it.
I'm not perfect. I definitely make mistakes sometimes in grading, or I write things that are not clear. So please do not have any hesitation to ask any questions about things. Some of you did well, some of you struggled. If it didn't work out the way you wanted it to, then let's talk about what you're going to do differently going forward. You're not going to get different results if you keep doing the same stuff.
Wait,
This might be the point where you're not automatically going to do well in a math class anymore. That was probably going to happen. You were going to keep taking math, and it was going to keep happening. Okay, I don't know why. Okay, I need this back from you when you leave, before you leave, or when you're leaving. Do not leave with it. Do not leave with it. And if you're done looking at it and you want to give it back to me right now, that's fine. Just put it in my hand. Thank you. Oh, I'm sorry. Where did I put yours down? I put it down. Sorry, because we're after school. And I put it. No, you're fine. I wonder if I put it. Okay. 14. Okay. So you plug in B, you get 0 over 0. 0 over 0 is not 0. 0 over 0 means more work. So factoring this to try to get an x minus b factor. So I would need a 2x. So 2x times x would make the 2x squared. And I would need a plus b.
Why don't you take a
Those are divide, and then I can take the limit as x approaches b of 2x over b. That's 2b plus b.
Are you ready?
All right. Yes. Yes. Yeah. Yeah. So that point is for your limit notation. Because when you write the limit, so there's a. It's more about that equal. You have the limit as x approaches -2 from the left equals. Okay, so you don't have a limit of a function. You have the limit of nothing equals a function. So you would have had to I know, and it's so teeny tiny, but that's why we put extra points in for those things. So it would look like that. Okay. So that's and so same kind of thing up here. We put the limits of nothing. So both of these points were notation points. Alright. Yes. Oh, you can either, if you're done looking at it, you can just hand it to me and you can jump line to do that, or you can.
You know why?
Do I know why?
I don't know why.
Yeah. Oh, you don't know why. Okay, so you lost 2 points. One here and one here. Actually, my hand would be great. Yeah, I want to keep it. That's okay. Thanks.
So maybe he doesn't like.
Those have to do with limit notation. The limit as x approaches 3 from the left is of the function is not equal to that function. It's equal to this. So that's why I think that can't be there. And you did the same thing down here. So both of those were the way you wrote it.
Also, your recording is
Oh, it is still on. Okay. Thank you.